Things that are going to be on your test tomorrow. And we've got your review sheet coming. First off, 30, 60, 90, 45, 45, 90 triangles. Here's a 45, 45, 90. Here's the relationship you need to know. If you have a leg of the 45, 45, 90, well, all of a sudden you have both legs. Because the 45, 45, 90 is an isosceles triangle. You have two congruent angles, you will have two congruent sides. So if that's 5, this is 5. From there, if you want to, you can do Pythagorean theorem. I don't suggest it. We're learning shortcuts. So if this is 5, this is 5. To go from leg to hypotenuse, you simply take 5 and multiply it by root 2. That's it. If you've got to do that backwards, what if you're given the hypotenuse? To go from leg to hypotenuse, you multiply by root 2. So to go from hypotenuse back to leg, you divide by root 2. That's the leg, 6 divided by root 2. But we just don't leave our answer like that. We want to clean it up. We want to get the radical off the bottom. To get a radical off the bottom, if you got root 2 on bottom, multiply top and bottom by root 2. You now have 6 root 2 over root 2 times root 2 is 2. You cannot divide a radical by a number. That's the reason you couldn't do actually 6 divided by root 2, but you can divide a number by a number. You have 6 divided by 2 now, which is 3 root 2. If that leg's 3 root 2, then this leg is 3 root 2. Check yourself. It should be to the point to where you can take a leg, multiply it by root 2, and it should give you hypotenuse. 3 root 2 times root 2. What is root 2 times root 2? 2. 3 times 2 is 6. It checks out. Okay, 30, 60, 90. And use whatever method that you like. If you like, if I do it different from Coach Thrash, you like the way he does it, do it that way. I'm concerned about right answers. That's it. Right answers with no copying. That's all I'm concerned with. I don't care how you get it. Now, there's 3 different ways that I could present this problem to you. I could give you, this is the easiest of the 3. I could give you the short leg. And I call it the short leg because it's across from the 30. The 30 is the smallest angle. This is going to be the smallest side. Everything revolves around that small side. If the small side is 6, how do you go from small side to hypotenuse? Double it. Done. How do you go from small side to medium side, I guess you could say? Multiply by root 3. Done. Now here's your tip. Whether you multiply by root 2 or root 3, some people confuse that, and some people might put 6 root 2 there. In a 45, 45, 90, 5, 5, 5 root 2. In a 45, 45, 90, that's when you multiply by root 2. How do I remember that? What's true about 45, 45, 90s? They're what kind of triangles? Isosceles, so how many of the legs are equal? 2. That's how I remember it. 2 legs are the same, that's when I multiply by root 2. All 3 legs are different, that's where I multiply by root 3. Okay, that's one scenario here. Let's look at your other scenario. What if I gave you, here's the other easy one, sometimes. What if I give you the hypotenuse is 20? There you go. Everything revolves around this side. You have to go here first. If you're given this is 20, this is 10. If you're given this is 10, this is 10 root 3. Done. Now let's work a hard one though, where it's a decimal or something. 20, 10, 10 root 3. What if it was 7? There we go. Man, that's ugly. I don't care. The only thing, if it's multiple choice, this would be 3.5, and this would be 3.5 root 3. Or they might do this to you. If it's multiple choice, they might just leave that as 7 divided by 2. 7 halves. And that would be 7 root 3. Multiply by root 3. So this would be 7 halves times root 3, or they might write it as 7 root 3 over 2. So you might see your answers written like that as well. Okay, last scenario and the hardest of the hardest of the three. What if they give you the long side? Let's say it's 6. Remind me, if you're given short side, to go from here to here, you double. From short side to hypotenuse, you double. From short side to medium side, you multiply by root 3. So how do I go from here back to here? If you multiply by root 3 to go here, then you divide by root 3 to go back. 6 divided by root 3. That is where you're going to miss these problems on your test tomorrow. I can already tell you because I've given this test for the past 12 to 15 years. So that right there is where you're going to miss it. So if you want to star that. To divide 6 by root 3, multiply top and bottom by root 3. You now have 6 root 3 over root 3 times root 3 is 3. You can divide numbers. 6 divided by 3 is 2. 2 root 3. Check yourself. I should be able to take that, multiply it by root 3 to give me 6. 2 root 3 times root 3 is the same thing as 2 times 3, which is 6. To go from here to here, we have to double it. I think of 2 root 3s as kind of like 2 apples, 2 oranges, 2 whatevers, 2 elephants. If you double 2 elephants, you have 4 elephants. Okay? To double this, you simply double the number out front, 4 root 3. Okay? 2 of them, you now have 4 of them. Make sure that you know SOHCAHTOA. And there's actually several different ways I could present this to you. SOHCAHTOA. I could ask you what's the sine of A, what's cosine of A, what's tangent of A, what's the sine of B, cosine of B, tangent of B. That's one way I could look at it. Yeah, raise your head up, bud. Thanks, sir. If I ask you for the sine of A, O and H, Garrett, what does that stand for? Hey, boy, perfect. O stands for opposite, H stands for hypotenuse. If I ask you for the sine of A, Peyton, what is opposite of A? And hypotenuse is 5, so the sine of A is 4/5. I could ask you for the tangent of B. If I say, what is the tangent of B, you would tell me, Tessa, tangent is opposite over adjacent. What's opposite of B, Tessa? 4. Careful. B. 3, and adjacent would be 4. So tangent of B is 3/4. Now, here's the confusion some people have with this. If I say, what is the tan of B, you tell me 3/4. I don't think it's going to be written as a decimal, but you could divide 3 divided by 4, that's 0.75. Just in case, I don't think they're going to. But what if I ask you for B? What if I don't say, what is tan B? What if I ask you for B? How do you find B? You move the tan over by doing inverse tan. Okay, on this problem here, I'm not asking you to find the angle. I'm not asking you to go through the process and tell me what the angle is. But from what you have there, you could go one more step and you could tell me the angle by using, like you said, inverse tan. Well, how big is that angle? So we'll call it about 37 degrees. Same thing with A. If I ask you what is sine of A, and I think I did a while ago, sine of A was 4/5. I'm not asking for A, I'm asking for the sine of A. I'm just asking for the first step. But now let's go finish it up. One more time, Trey, do you remember how to get rid of sine? What do I do to the other side? How do I move it across? Sine turns into, what kind of sine? Trey, there you are. Say it again. That's right, inverse sine. So to get rid of a sine on one side, make sure you know it tomorrow. To get rid of sine on one side, you do inverse sine of the other side. Anytime you're looking for an angle, if I ask you what is angle A, what is angle B, that's what you do. And if I'm not mistaken, you'll get 53 degrees, hopefully, when you do that. If you don't, everything's wrong. 53 or 52 point something, I don't know. Which there was an easier way of doing that. So that's one thing we could do is, okay, what is the tangent of A? What is sine of A? What is cosine B? Then we could ask you what is angle A, what is angle B, or we could give you this. We could give you the triangle and say we could give you an angle, such as 30 degrees, and we could say that this is X and this is 10. And if I give you this situation, it's the same thing. Let's work it the hard way. SOHCAHTOA. SOHCAHTOA. McKenna, look at that 30-degree angle. X is what in relation to the 30-degree angle? Good, and 10 is. And I believe if you're dealing with opposite and hypotenuse, that would be a sine problem. So you write yourself a little equation. The sine of 30 degrees is equal to opposite over hypotenuse. If you were taking your ACT test, here's what they would do. They would simply mark out 10, since it's divided by 10, and they would leave your answer, well, possibly not on this one, but 10 times sine of 30. You're going to take and put it in your calculator, right? Does anybody know what the sine of 30 is? Just right off the top of your head. What's the ratio in any 30, 60, 90 triangle? Take your 30-degree angle. What is the ratio of opposite to hypotenuse every time? What's the relationship between the short side and the hypotenuse in a 30, 60, 90? It's double. So the ratio of opposite to hypotenuse would be like 2 to 4, 5 to 10. It'll always be half, correct? So the sine of 30 is always half. And if you type this into your calculator already, you get 10 times a half, or 5, which was the hard way of working that. Okay, we know the easy way, right? 30, 60, 90. Everybody recognize this as a 30, 60, 90 right triangle, and we could have used our shortcut, but much faster. The relationship in the 30, 60, 90 between the hypotenuse and the short side is the short side will always be half. So could you use this to possibly, if you forget your 30, 60, 90 rules, could you use this to find it out? Probably. Let's do another one. Let's do one to where the what we're looking for is on bottom. Let's say this is a 50-degree angle. Let's see, that's opposite over adjacent, x and 12. Before we even start, will x be bigger or smaller than 12? Why? Careful, not 60, but it's not 60, but 40. So it's going to be smaller. Does everybody understand that? This is a 40-degree angle. This is a 50-degree angle. I tend to do that before I even start a problem. I kind of guesstimate about what it would be. Well, since it's opposite 40 and this is opposite 50, I'm guessing it's going to be about 10. Okay, now let's see if we're right. First, determine what kind of problem you have by using SOHCAHTOA. Some old hippie. SOHCAHTOA. This is opposite and adjacent. That's TOA. The tangent of my angle is equal to opposite over adjacent. Anytime I have an x on bottom, I automatically do this. And I solve it like a proportion. I do 1 times 12. The two numbers that are across from each other, you multiply, and then you divide by the third number, which is tan 50. So in my calculator, I would type in 12 divided by tan 50, and you get again. 10 even? 10 point. Wow, that was really close, wasn't it? 10.1. SOHCAHTOA only works for right triangles. When you have what's called oblique triangles, you have to use either law of sines or law of cosines. The law of sines says the sine of an angle divided by the side across from it is equal to the sine of an angle divided by the side across from it. A lot of people look at this problem, if I give it to you on the test, and say you can't use law of sines here. And people in pre-cal, I'll give the same problem to, and we still get tripped up on these. We're given a sine of 100 over 12, but here's my x. I don't have that angle. Yeah, I do. How big is it? 30. Thank you. So, because the 3 have to add up to 180. So you have sine of 100 over 12 equals the sine of 30 over x. This morning in pre-calculus, and you'll have to do the exact same thing. That wouldn't be a bad idea to go ahead and get them started on their common angles. Well, I think we talked about that. they have to memorize the sine of 30, sine of 45, sine of 60, cosine of 30, 45, 60, the tangent of 30, 45, and 60, because they're nice, neat whole numbers, and I might force y'all to do the exact same thing for some bonus points somewhere down the road. But the sine of 30 you already know. We did that one a while ago. In a 30, 60, 90, the ratio of opposite to hypotenuse in a 30 degree of the 30 degree angle would be, do you remember what it was? Half. Yeah, that's a half. So you have, okay, let's solve this. This is a proportion. These two numbers are diagonal, so we're going to do 12 times sine of 30. We already know what that is. That's 6, because that's 12 times a half. Divide that by sine of 100, and that gives you your x. And if you want to just type that in, if you know that, you could do 6 divided by sine of 100. It's just faster. And tell me what you get when you get it. So, my missing side is about 6.1. Question. Now that I have 12 and 6.1, can I use Pythagorean theorem to find the other side? No. No. Don't even think about it. This is not a right triangle. You can only use Pythagorean theorem if you're dealing with right triangles. How can I find the other side? Law of sines again. You can do the sine of 100 over 12 equals the sine of 50 over x, and that would give you that other missing side. Okay, law of sines again. Okay, another law of sines problem. And this is the ones, these are the biggies. Again, I would mark this. People miss these. X, 13, 30 degrees, 4. When you're looking for missing angles, now I added something to this, and whether it'll be on your test or not, probably not, but I do want you to know it just to make our lives easier next year in Algebra 2. You have the sine of 30. Man, I like that 30, I guess. You have the sine of 30 over 4 equals the sine of x over 13. I'm going to show you a little bit. I like his way. Okay? I'm going to show you another way, and you can work it either way. Here's how I do these problems. Again, I treat it like a proportion. I say, okay, this and this are diagonal. So I'm going to do 13 times the sine of 30. And I'm going to divide that by, since it's a proportion, I'm going to divide that by 4. When you type that into your calculator. Okay. Yeah, and it's, I'll explain. This is actually when you do inverse, but let me go through the steps. Okay, I did this times this divided by 4. That does not mean this angle is 1.625. Because when you do this times this and you divide it by this, that doesn't give you x. You see what it gives you? Sine x. You would still actually have one more step. This times this divided by this, shortcut gives you sine x. So now you have sine of x equals 1.625. When you move the sign over by doing inverse sine, you actually get an error. The reason you get an error is because I made this problem up. And there's no triangle that can satisfy that. Why is that true? Here's my explanation of that. A 30-degree angle is across from a side of 4. So how big would this angle have to be in order to be across from a side of 13? Probably like 180 degrees, 170. It'd have to be huge. And why is there no triangle that satisfies that? Because, well, they can only add up to 180. So this angle can't be any bigger than like 149.9. And what it did is it's such a big triangle that it doesn't satisfy that. So let's work another one of those to where we actually do get an answer. Okay. So here we go. Again, sine 60. And that's actually one of the common angles you'll memorize as well. Sine of 60 over 7 equals the sine of x over 8. Shortcut is this. You will type that in as shortcut 8 times sine 60. 8 times sine 60. Enter. You'll divide that by 7. And here's how you'll always know. The reason as soon as I saw that 1.625, I knew that it wasn't possible. Because let's go back to what sine means. I'm going off on tangents now. Y'all just bear with me. Isn't sine opposite over hypotenuse? What do you know is true about the hypotenuse of a right triangle? It's always the longest. So if you have the opposite, will the opposite side ever be as big as the hypotenuse? No. So do you see that this opposite over hypotenuse, since the hypotenuse is the biggest, that the opposite will always be smaller than that? So you'll have like stuff like 6 over 8 or 7 over 12. Or what's going to be true about the sine? It'll never be bigger than 1. Never. So when I got that the sine was 1.625 or whatever, I knew that's bad. Okay, that's not possible. So there was no triangle satisfied that. So if you ever get a sine or cosine for that matter, if you ever get a sine or cosine that's bigger than 1, it'll be an error message. It'll be no solution. But you don't have to know that. You'll get used to it. But now let's go back to this. In my calculator, I typed it, and I'm good here, 0.98. I'm fine with that. So I multiplied this times this. I divided by 7. That answer is the sine of x. So now you have the sine of x equals about 0.98, I think. To move the sine over, I've got to take my calculator, and I've got to take this answer and find the inverse sine. Let me show you how to use this calculator. It's kind of come in handy as well. I don't want to type all that in again, and I might have already showed you this. Above the negative sign, you have A and S. If you want to do the inverse sine of this, type in the inverse sine of the answer. Type it in like that, and that'll do the inverse sine of the previous one, which is about 82 degrees. That worked out better. And then you could go on further. That tells you that the other angle would be, I think, 38 degrees. You could do law of sines again and find the other one. But from yesterday, from the other day, 82 degrees is not your only answer. It could be 82 or 98 degrees. Your calculator only gives you one of the answers. To find the other answer, you do the supplement of that angle. Okay. Let's. Here's my test, though. To figure out which one you're going to use, sines or cosines, try sines first. Always try sines first. Sines is a whole lot easier to use. That'd be the sine of 50 over x equals, that's the only angle I have. You can't use law of sines. In order to use law of sines, you would have to have this relationship plus another angle that goes with one of these sides. You don't have that. Or if you have a side and an angle, and you have a side and you're looking for the other angle, you need two side angle relationships in order to use law of sines. You do not have that here. You have to use law of cosines. Here's how the law of cosines works. Here is the law of cosines. A squared equals b squared plus c squared minus 2bc times cosine A. To where A is across from, this is angle A, side A is the one across from it. So in the place of the A, we have x squared equals, it doesn't matter which one's B and C, so you have 6 squared plus 8 squared, minus 2 times 6 times 8, times the cosine of whatever that angle was, 50 degrees. Sure. Yeah. What I would do on this, so that to save myself some time, guys, you want to know what x is, right? Just square root that whole thing. To get rid of a square root, and then you can just type that straight into your calculator. Somebody type it in while I'm answering the phone. So x is about 8.3. Okay, just kidding. So x is about 6 point, say again, 2. Here you go, Teeter. Watch this, and I'll plug it in. Just see if you can figure out, and probably just put a wrong number somewhere. You've got, come on, the square root. And do you see why I saved that step? Don't type all that in and then take the square root. Just put a square root over the whole thing. So you got the square root of 6 squared plus 8 squared. 6 squared plus 8 squared. Minus 2 times 6 times 8. Minus 2 times 6 times 8. Times the cosine of 50. close parentheses for the cosine, close parentheses for the square root. Got 6.2. So just double check me, Teeter, and see if you can figure out where you missed it. Okay, last scenario, and I'm done. Got an error. Given this scenario, if you've got a triangle with all three sides, it has to be law of cosines for any angle. We'll look for the big angle. Should be the biggest of the three. Law of cosines says a squared, and the a's in your formula, if you're dealing with the a squared and the cosine a type of formula, those will always be the two that are across from each other. So you have 10 squared equals, the other two don't matter, 5 squared plus 6 squared minus 2 times 5 times 6 times the cosine of x. I do want to caution you of something here. Here's where this problem's always missed. See if you were about to do this. A lot of people put all that stuff together right there. They'll do 25 plus 36, and then they'll subtract 60 from it. You can't. This is 25, you're correct. This is 36, but this is not just 60. This is 60 times cosine x. That cosine x is attached to this. These are like terms. You can't add those. You can't combine. This is not a like term. You don't see any cosine x's hanging around here, right? But you've got this cosine x attached to this. So here's what I do. I think I told you the other day. Here's how I type this straight into my calculator. I go ahead and move this over, and I move this over. You now have 10 squared minus 5 squared minus 6 squared. I go ahead and put it in parentheses. Make sure when you do it in your calculator you do as well if you want to type the whole thing in. So I've moved that, I've moved that. I'm left with this. This stuff is being multiplied. To move it over, I'm going to divide by it. So if you want to go ahead and just write that as negative 60, that's fine. Equals cosine x. And if you want to do it all at once, go ahead and move your cosine over too. Pacey, how would you move cosine over here? Careful. Cosine is moved over by doing the inverse cosine. If you're looking for the angle, does that make sense? If you got sine, you want to get rid of sine to find the angle, you do the inverse of sine. If you get rid of cosine, move it over. So your actual answer, folks, if you want to type it all in one big step, is this. And I could very well see the ACT leaving an answer like that because, again, you don't have to have a calculator. Now, you could clean up the top some. I'm going to do that just for the fun of it. So that'd be the inverse cosine of 100 minus 25 is 75 minus 36 is 39. That'll divide by 3. You don't have to do all this because you can type it straight into your calculator now. 13/20. That's what would be on the ACT. That's how they would leave answer. But the negative or inverse cosine of negative 13/20, I do know that that's an obtuse angle. Should be bigger than 90. And I do know it's an accurate, or it will be an answer because it's less than, it's not a whole number. 20 is less than 13. So you have second cosine, see if this is what you got, of negative 13 over 20. 130 degrees, 131. Know what y'all got to? X is about 131 degrees, which makes sense. That's a huge angle down there. So what would this triangle actually look like? It would nearly be flat. So you have a 5, you have a 6, you have a 10. It's nearly isosceles and it's nearly flat because 131 degrees, that's a really spread out angle there.